Assalamu alaikum wa rahmatullahi wa barakatuh, dear students. In this video, we continue chapter 4, factorials. Example, 4 factorial is shorted for 4 times 3 times 2 times 1. The factorial function, this sample, says to multiply all the whole numbers from our chosen number down to 1. Examples, 4 factorial equal 4 times 3 times 2 times 1 equal 24. 7 factorial equal 7 times 6 times 5 times 4 times 3 times 2 times 1 equal 5040. Factorial 1 is equal 1. We usually say, for example, 4 factorial, but people say 4 shirk or 4 bank. To work out 6 factorial, multiply 6 by 120 to get 720. To work out 7 factorial, multiply 7 by 720 to get 5040, and so on. Here example, 9 factorial equal 362,000 and 300 and 880. Try to calculate 10 factorial. So 10 factorial equal 10 times 9 factorial. So 10 factorial equal 10 times the value of 9 factorial equal 362,880. So it equal this number. So the rule is factorial n equal n times n minus 1 factorial, which says the factorial of any number is that number times the factorial of that number minus 1. So 10 factorial equal 10 times 9 factorial, and factorial 125 factorial equal 125 factorial times 124 factorial. Actually, you can calculate factorial quickly by your calculator. What about 10 factorial? 0 factorial is interesting. It is generally agreed that 10 factorial equal 1. Combinations and permutations. What's the difference? In English, we use the word combination loosely or without thinking if the order of things is important. In other words, my fruit salad is a combination of apples, grapes, and bananas. We don't care what order the fruits are in. They could also be bananas, grapes, and apples, or grapes, apples, and bananas. It is the same fruit salad. The combination to save this log is 4 7 2. Now we do care about the order. 7 2 4 will not work, nor will 2 4 7. It has to be exactly 4 7 2. So in mathematics we use more precise language. When the order doesn't matter, it is a combination. When the order does matter, important, it is a permutation. Permutations with repetition. These are the easiest to calculate. When a thing has n different types, we have n choices each time. For example, choosing 3 of those things, the permutations are n times n times n, n multiplied 3 times. More generally, choosing r of something that has n different types, the permutations are n times n times n times r times. In other words, there are n possibilities for the first choice. Then there are n possibilities for the second choice, and so on, multiplying each time. which is easier to write down using an exponent of r. So n times n times n times r times equal n exponent r. Example, in the log above, there are 10 numbers to choose from 0 to 9, and we choose 3 of them. So 10 times 10 times 3 times equal 10 exponent 3 will give us 1000 permutations. So the formula is simply n exponent r, where n is the number of things to choose from, and we choose r of them. Repetition is allowed and order matters. Important. Permutations without repetition. In this case, we have to reduce the number of available choices each time. Example, what order could 16 balls be in? After choosing says number 14, we cannot choose it again. So our first choice has 16 possibilities, and our next choice has 15 possibilities, then 14, 13, 12, 11, and so on. And the total permutations are 16 times 15 times 14 times 13 and so on. But maybe we don't want to choose them all, just 3 of them, and that's then 16 times 15 times 14 equal 3360. In other words, there are 3360 different ways that the 3 balls could be arranged out of 16 balls. The formula is written factorial n over n minus r factorial. When n is the number of things to choose from, and we choose r of them, no repetitions, order matters. Important. Example, our order of 3 out of 16 balls example is factorial 16 over 16 minus 3 factorial equal factorial 16 factorial over 13 factorial. That will give us by your calculator 3360, or which is just the same as 16 times 15 times 14. Here is another example. How many ways can first and second place be awarded to 10 people? So factorial 10 factorial over 10 minus 2 factorial. That will give us 10 factorial over 11 factorial. By your calculator you can get 90. Notations. Instead of writing the whole formula, people use different notations such as these. P bracket n choose r, or n permutation from r equal n factorial over n minus r factorial. Example here. Now we are explain combinations notation, as well as at the big parentheses. People also use these notations. C bracket n choose r, C this for combination, equal n combination of r equal factorial n factorial over r factorial times n minus r factorial. Just remember the formula. Pool balls without order. So our pool example now without order is 16 factorial over 3 factorial times 16 minus 3 factorial equal 16 factorial over 3 factorial times 13 factorial. By use calculator, your calculator, you can will find 560. Or we could do it this way: 16 times 15 times 14 times 13 factorial, and we cancel with in the denominator 13 factorial cancel, and 3 factorial is 3 times 2 times 1. and by your calculator you will get 560. It is interesting to also note how this formula is nice and symmetrical. So n factorial over r factorial times n minus r factorial equal n combination r equal n combination n minus r. At this point we finish this video. Next video we are going to explain the probability. Thank you for your listening.